In this video, we will talk about the curves inside Houdini. We will recreate a curve from our resampled curve inside Vex using the primUV function, which is a very useful function. And then we will create a gradient for this curve, and we're going to use this gradient to drive our height of our copy to points boxes that we created. So at the end of it, we should be able to learn about the primUVs and change the height of our boxes with the channel ramp, like that. Let's start with the most basic curve. So let's put down the curve node. Let's just go to the top and let's redraw it, something like that, and let's resample it. Let's make it subdivision curves, maybe something like that. And now let's use the Vex wrangle node. Let's use the function that's probably some of the most useful, especially working with the curves, which is the primUVs, which is basically the intrinsic UVs of the curves or for any polygon. So let's just take a look at it, and first of all, let's open up the help of it. So primUV is interpolate the value of attribute at the certain parametric UVW position. So basically, you have to imagine like this curve has a UVs, even though we do not have a UVs anything it has here, or even if you put down a box, you go inside here, you won't see UVs, but with this function, there's basically intrinsic primitive UVs. You can think about them as if, let's say, this box is basically every primitive is basically laid out in a UV space like that. So it doesn't matter if it's a square or whatever. Basically, imagine every primitive of every object is just laid out inside the UV space, 0 to 1 space, like that, and we do not need any UVs to actually get this information from. So this is basically how it's going to work. And now to demonstrate maybe a little bit more easier way, let's add 1 point to each primitive for our box. So since our box is actually a square and our UV space is also a square, it's easy for us to visualize that every one of these squares would be basically inside all of these 0 to 1 UV space. So let's think about this. So theoretically, the very center should be at 0.5 and 0.5 at the UV space. So let's actually do that. So I'm going to create a vector, let's say point pos. Let's create actually so we can iteratively change it. Let's actually create a vector channel for parameters. So like that. Let's use our primUV function. So it's going to return the type of the data type that we actually asked for. So since we want position, that's going to be a vector. Let's call the new point position. That's going to be primUV. So geometry is going to be 0. Attribute name is going to be position, P. Primitive number is going to be at primnum. And UVW is going to be our PT position. So we are basically giving this position for us to add this point. And let's run our primitives, since it makes more sense, since even for every primitive add 1 point. So let's add our channel. Let's go to 0.5, copy and paste inside here. And now we actually have to add our position. So add point 0, and the point number is going to be a position for it. So a new PT position, like that. You can see we have added point to every one of the center of each polygon. And if we change it this one, you can see all of them are basically moving around at the same place, at the same pace. So, and we can move around. And since we don't really need the channel because UVs are two-dimensional, so don't change anything there, but you can easily see what this primUV function does. So it's very powerful. And let's get back to our sample and how can we get some information from our curve. To use prim UV function of our curve, it's actually even simpler. We just have to give it a one single float value between 0 and 1. You can think about it as if, since this is just a one primitive, an entirety of any of these attributes on our curve can be accessed by giving a one single float value. And if you take a look at the UVs, you can think about it as the entire curve flattened out and put inside along the very bottom of our UV space. And since it doesn't really have any thickness, it just has a length. So it's basically just a one kind of just a one value that can be useful for us to interpolate any of the values along the curve. So to demonstrate it, I'm just going to remake this curve with the ability to change how many points we have and how long our curve is going to be. Let's start by creating a couple of parameters for us to change interactively so we can see the result. So let's get the int value of point count. There's going to be an integer channel. And let's actually duplicate it. Let's call it curve length. And it's going to be a float. And let's call it curve length, like that. Let's create these parameters. So let's start by 40. Curve length should be f. My bad. So let's clear out. So let's put it to the 1. Let's start by running a loop over the over the point count. So let's put a for loop and want to counter to be a pt count. And now what we're going to do is let's create our float value. Let's call it the UVWs, which is just a float value that's going to sample the attributes from our curve. So it's pretty simple. What I'm going to do is make sure that for every loop it's slowly creeping to the 1. It starts at the 0 and it ends with the last loop at the 1. So all we have to do is basically divide the current loop value, which is y, by the total number of point count. And for now I'm just going to also subtract 1.0 from it. So we can do it many ways. We can also do it by making sure that it's smaller or equals with the pt count, because think about it. So let's say our first value is 0. That's fine. 0 divided by pt count is going to be 0. So we started very well. But let's say at the very end of the loop, this loop is not going to run if we have if let's say point count is right now 40, and at the very end of the loop, this is actually not going to run, because this runs only if the pt count is if the y is smaller than the pt count. So it's going to stop at the 39, but we want to get our 1 value, and so basically it will be at the very end, it will be only 39 divided by 40. So that's why we basically just subtract 1 value at the end of it, so that at the end, very last loop, it's going to be 39 divided by 39, it's going to be 1. We could also do it by basically smaller or equals with the pt count, like that, but also we have to make sure that this actually casts as a float, because if we do not subtract or cast any of these values as a float, it's going to return integer value, and we want our decimals also. So like now we have our UVWs, and let's get our position. So going to vector, let's call the position prim UV. Geometry is going to be 1, attribute name is going to be p, and prim num is going to be the value. Actually, the primitive is going to be since we have only one primitive, it's going to be by default, it's going to be 0, because it starts with 0, and UVW is going to be our UVW that we just got, like that. Now let's add our point, add to the 0, and point number is going to be position, like that. And you can see we have our points recreated, like that. You can see we can change the amount of points. You can see it's basically interpolates the position values, and we can add our points. So there's a couple problems obviously here. First of all, we don't have a curve, so we have to fix that, and also we want to change our length. And our length right now does nothing, but it's very simple. All we have to do is at the end of it, at the end of all of this, we just have to multiply it by. And let's multiply it by already channel we have, which is the curve length, like that. And you can see now we change the value because basically at the very end of this it multiplies by, let's say the max one is 1, and basically just multiply by 1, which means do nothing. But if we have any of this float, our curve is basically becomes a smaller one, like that. Let's actually get our curves. Let's actually create a curve suite. So first of all, let's create a primitive. Add prim. This is you want to do outside the loop, because for curves it's only one primitive. So since we run over detail, I just want to one primitive, and let's call it a new prim. Since it's we know the index is going to be 0 because it's just a one curve, but it doesn't really hurt us for us to also get the new prim variable. So it's going to be a polyline, like that. And now all we have to do is add our point, and also for the point we have to give it a point number. So for this point number we can actually use our counter as an I, or we can use the variable that we add for our add point. So int new pt, like that. And let's add our vertex 0. Prim number is going to be new prim, and the point number is going to be new point, like that. You can see now we have our point. We have basically recreated our curve, and let's actually make sure that we have the same amount of, so 35 points. So you can see it's basically identical to this curve. You can see there's basically no changes to it. So we have recreated this curve, and actually change, we can even for the add point, instead of, let's use our counter as the point, like that. So actually delete this. So that's that. And now let's calculate gradient for our curve, which should be basically giving every point, it's basically a UVW position for it. So we get from 0 to 1 a gradient for our curve. So we can do it a couple of ways. So first of all, let's do the multiply later, because we want our gradient to be between 0 and 1 independently of the current state of this curve length. So let's do it by, let's do this like that. So I'm going to copy this, delete this, and right now it's the same. Let's actually set this this value. So set point value, set point attribute 0. Let's call it gradient. Point number is going to be I, and value is going to be position. It's not the position, but UVW, like that. Its mode is going to be deleted, like that. So you'll see now our gradient is always going to be between 0 and 1, but you see that our curve length right now doesn't work because we do not multiply it by. We want to do our multiply later after the gradient. So after we have written out this variable UVW, basically we do not want to alternate our UVW value. We're going to multiply right where we actually give its value to the prim UV function. So I'm just going to paste it at the curve length, like that. So this is going to ensure that our gradient is always going to be between 0 and 1, independent of the location of our curve where we want to how long it's going to be. See, the values always change, but our UVs are always the same for every point of it. The gradient is always the same. So let's actually, I'm going to delete this. Not delete, but just change it. And let's say if we did it by multiplying by UVW like we had before, our gradient is going to change. Our maximal gradient is going to be the maximum gradient of our curve. So you see that the maximum, like now it's 0.702, and our maximum gradient is going to be also that. So it's basically going to clip it at that. So depends on what you're looking for, but I like my gradient to be always be 0 to 1, independent of the length of it, like that. And with this gradient, we can, let's say, put down a copy to points and use it kind of like a group. Let's put down a box. Let's say I want to copy to the curve, but I want to only copy let's say the first part of the curve. It should be at gradient is smaller than 0.5, like that. You see, it basically works as a group and copy it only to the first part of the curve. And let's actually do some more examples, but for that, let's actually animate this curve. So let's say I want to start with the inside here. So let's press Alt on it. Let's go to the maybe 150 frames, and let's press it like here. So we scrub the timeline, and you just press Alt to get the value of it, like that. You can see we have basically now copying only to the first half of the curves, always. Let's actually visualize this one, like that. Another benefit for our gradient is actually that we can recalculate the gradient with the channel ramp. So let's copy to points some object. So what I'm going to do is actually, let's call it this gradient, let's rename it to the pscale, so that it would be automatically picked up by the copy to curves. So let's put down copy to curves, and let's create some box, maybe something like this. Let's copy it, and you can see obviously it's going to, let's pick the next edge, and let's orientate it to the z-axis actually. So just I mean, Houdini wants any object that we copy to be around facing the z-axis, like that. So it's actually correctly aligned to the next point, like that. And let's actually I'll just resample our code to maybe less points, something like this, like that. Let's actually leave our gradient intact. So let's go back to here and let's put the gradient. Let's put down another wrangle node, and just it's totally fine. Sometimes you just want to another wrangle that does specific thing, and not to be all messed up with all of the code in one wrangle node. So let's go through the points, and what we'll do is set our pscale. So let's create our channel ramp. So it's going to be a float. So let's call it a ramp, and it's ch ramp, and then we have to give it a name. Let's say scale ramp, and then it asks for the input of the float that you want to basically resample, reassign. So it really expects values between 0 and 1. So that's what we have. We have our gradient value, and let's just, since we are running over the points, we can just f at gradient, and we can now just let's add our gradient, let's just create our pscale. So f at pscale equals ramp, and that's it. We have now basically the same pscale, only now we are controlling it with the ramp like that. And one last thing is I want to show that this copy to course actually copied to our points that we duplicated along with the basically the whole primitive. It's actually also gave the values of that point that we copied to our primitives that we copied. So you can see that we have for every box we have 8 points, and in here we have 8 zeros and 8 each one of these gradients. So basically you can say that we basically get the copy of our gradient to our primitive. So let's actually use this information with the gradient, and let's move every one of these. Let's control with the channel ramp the basically every one of these pieces top polygon, so we can change the height of it with the ramp. So let's start by putting it for each loop, for each connected piece. So what we want to do is actually convert this gradient, every one of these values, to the integer primitive attribute. So that's why this connectivity is actually automatically given. So attribute that we want to convert is our gradient, and we want to convert it to the integer. Let's just connect it inside here. So you'll see our gradient is going to still be here, but inside our primitive you can see there's now a 6 values for each primitive. That's going to be 0, 1, and all of that. So because this for each loop actually acts for the primitive for the integer attribute called, well, we're going to call it let's not call it gradient, so let's call it piece. Well, it's automatically by class, but let's call it a piece like that. You can see it's basically now automatically sorted by the ones that are the same attribute value by 0, basically 24 values, which is exactly amount of points we have for our point. So like that. So we can't really you would think that since it's asks for the piece attribute, you could just automatically put it like well, first of all, it's since we want to run over the primitives with the points, it's actually not going to work. So this is the way we have to do it, and it just is what it is. So make sure you have this setup. And now for our randomness, let's put down a transformer on. And what's cool about this is that basically our polygon selection is always going to be the same in the basically the same point number for the primitive. So you see it's a 5 inside here, and let's put in a single pass, and it's always going to be so like that. It's always going to be 5 at the top of this, so the polygon is always going to be 5. That's why we can in a group just put down a 5. You can see we are now just moving the 5th polygon, the very top of it, like that. So that's very nice. Let's turn off the single pass. And now for introducing our randomness, it's pretty simple. Let's put in create meta import node. So this is basically going to be what is actually going to change for each loop. So for each loop, our iteration is actually going to change, and the values are going to change. So this is basically our dynamic kind of dynamic element. So let's put in a wrangle. And wrangle, we want to get a couple of things. Let's connect our geometry that we just get inside here to our wrangle second input. And since this wrangle is going to run over 24 times, it's make sure that it's at detail. And let's start by getting the gradient of that piece. So let's go for the float grad value. Let's call it let's get the, since it's a point, geometry is going to be 1 gradient. So the point number, since all of the gradients for this point, for basically for each loop, is going to be the same, it doesn't really matter. So let's just select the 0 point gradient. Let's create our ramp. So it's going to be a float ramp ch ramp channel, let's call it attrib ramp, actually hiked ramp, and position is going to be our grad value, like that. So, and right now we can basically just, to check it out if it actually works, let's just apply this value, this ramp to our transform, which is pretty simple. Let's create a attribute from it. So since we are running over the details, we can actually create a detail attribute. So f at let's call it the hiked equals ramp. So now for each loop, there's going to be a hiked attribute for each loop that we can reference inside our transform. So let's create it, and let's just move something that it would be obvious that we have actually done it right. So something like that. Now let's go to the transform, and let's reference our Y channel. We can actually go to the reference, scene data, select the attribute wrangle node, attributes, global, and use the height that we just created, like that. So you see, it's already working. We are basically changing that value by that much. And as the last thing, let's make our ramp a little bit more user-friendly. So let's delete all of the points except for one. And for this one, let's put it to the 0.5. So what I want to do is actually make sure that this 0.5 is going to be kind of a baseline. So 0.5 on my gradient would be equivalent to the 0 on transform, on translate y-axis. So that basically does nothing. And then if I want it lower or above, I would control it inside here. So all we really have to do is refit this ramp. So what you can do is actually let's just use the same variable ramp. We're basically overwriting it with the fit function. So the value that we want to refit is ramp. The original min is 0, original max is 1, and the new one is going to be a channel ch f min, and the same with the chf max, like that. Close it down, and since we are basically overriding this value, it should work very nicely. So let's take a look at it. So for my min and max, it's going to be 0.5, negative 0.5, and positive 0.5, and the middle value between them is exactly 0. So let's delete it. You can see, let's put it to the 0.5. This transform is going to be 0 for every one of these. So basically we have not done any transforms. And if I want more or less on it, I can just move it on like that. And if we are like working with different scales, we can basically implement the overall scale width at the very end of it. So at the ramp, we just multiply it by chf multiply, like that. Let's add the channel. Let's take a look at it. So this would basically kind of multiply the values that we have inside here. So basically, let's remove these and let's add the as a Bezier curves. So that will be maybe a little bit more, organic looking, like that. And for our multiply, you can see if I increase my multiply, it's going to basically exaggerate our curve that we just created. Now let's just create a new curve. Let's maybe something like this. You can see it's all editable inside here with the different curves, like that. And if we go around changing the values, you can see our curve is still preserved because it follows the gradient, like that. So I think that's it for this video. Hope you learned something, and see you next time.